Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. So now for the next one, we're done with U-Substitution with indefinite integrals, which this is when you say uh-oh, because that's right, we're doing definite integrals this time with U-Substitution. Now, is it harder? Yes. Is it that much harder? I'm going to say kind of. So 4x minus 6, this whole thing's going to be cubed, and then we have dx. So first of all, notice this could be a definite integral or an indefinite integral. Like the only thing that's different between a definite and an indefinite integral takes place after we take the integral. What am I trying to say? The process for U-substitution is pretty much exactly the same. I just choose my u, I find du dx, I plug in, I cancel out, I hope that the integral works, and then I take the integral. All that stays the same. Now, what do I choose for the u here? Notice I can't use my Goldilocks method. Oh no, because I only have two things here. I have the thing in the parentheses, and I have the thing in parentheses cubed. I think you can guess this, but if you can't, you know what happens already when you choose the wrong thing. So I'm going to tell you, u is going to equal the thing in the parentheses, as it is most of the time. It's a good rule of thumb. It's not every time. A lot of it is trial and error until you start to pick up the pattern of choosing the right u. But in this case, u is going to equal 4x minus 6, which means du dx, the derivative, is equal to the derivative of 4x minus 6, which is just 4. Then multiply both sides by dx, du equals 4 dx, and divide both sides by 4. Dx equals du divided by 4. Perfect. Now I'm going to plug in for dx and for u. I'm going to get the integral from 1 to 2 of, now it's u cubed, u cubed times dx is now du over 4. This is when you say, uh-oh, nothing canceled, and you would be correct. Now, did I choose the right u for my U-substitution, though? I did choose the right U-substitution. How? Well, it doesn't need to cancel out. Remember, the x's just need to be gone. Do you see any x's here? Nope. Then we chose the right u. Perfect. So this is going to be the integral of 1/4 integral from 1 to 2. Oh, and it's 1/4 because this 4 is in the denominator, and it's a coefficient, and I pulled it out in front. So 1/4 integral from 1 to 2 of u cubed du, and I know this integral because it's essentially what we've been doing all night. It's the 1/4, again, the coefficient, times u to the 4th divided by 4. I added 1 to my exponent, so 3 plus 1 is 4, divided by 4, there we go. And then again, I'm going to plug in the bounds 2 to 1. Now, if you plug in right now, you're going to make a huge mistake. What's the mistake? That's a rhetorical question. You don't need to answer it. I forgot to plug in for u. Don't forget that. Also, this 4 and this 4 in the denominator, I can combine to just be a 16. So it's 16 in the denominator. In the numerator, 4x minus 6. 4x minus 6 to the 4th power. Okay, great. So now all I need to do is plug in the bounds. 2 minus 1. We're going to get 4 times 2 minus 6 raised to the 4th divided by 16 minus 4 minus 6 raised to the 4th divided by 16. Let's see what this is. So 4 times 2 is 8, 8 minus 6 is 2, and 2 to the 4th power is 16. 16 sixteenths, that's actually just 1, pretty cool. Minus 4 minus 6 is negative 2. Negative 2 to the 4th power becomes positive 16. Positive 16 over 16. Look at that, we actually just get a final answer of 0. Ain't that cool? Yes, Dan. Okay, thank you. Thank you. Now there's one more thing I want to say about this problem, and that is there's another way of solving it. Do you remember back when we were doing extrema and we said we had the first derivative test with the number line, and then we had the second derivative test, and everyone liked the first derivative test, and we all collectively hated the second derivative test, but then sometimes we were forced to use the second derivative test? Well, we're going to have those exact same feelings right now, where the method that I just used, where we plug in back for u, and we plug in the points, that's one way of solving the problem. There is another way, and it's called, I don't know if it has a name, but this is what I call it, change the bounds. Change the bounds. So I would say from like a very technical perspective, this is the right way to solve an integral. And the way we did it before was technically wrong because the bounds, when we use a U-substitution, we need to change the bounds or else it's technically not correct. Now, will your professor care? No, of course not. No one cares. It's kind of an intermediate step. As long as we plug in x at the end, it doesn't matter. We get the same final answer. But sometimes you'll see questions where they ask you, hey, change the bounds. So that's a good question. Let's talk about that right now. So when it says change the bounds, and we did the U-substitution, u equals 4x minus 6, we said u equals 4x minus 6, and we had the integral from 1 to 2. I don't care what was inside it right now. Let's just stick with these facts. Integral from 1 to 2, we said u is equal to 4x minus 6. Technically what you need to do to change the bounds, you actually plug in 2 and 1 into my x points and find the new bounds. So this would be u equals 4 times 2 minus 6. I'm just plugging in 2 here into the u. My upper bound is now 8 minus 6, so positive 2. It actually stayed the same. Pretty cool. And then my lower bound would be u equals 4 times 1 minus 6. My new lower bound would then be negative 2. So in other words, if I had the integral from 1 to 2 in dx form, where I had, whatever the function was in the middle, then my new integral is the integral from negative 2 to positive 2, and that's when we have du. Again, I don't really care about this. Like, you don't need to solve it this way unless it specifically asks you. They wouldn't say change of bounds formula or anything like that. They would literally ask you, what are the new bounds after you use a U-substitution? They would ask you, what are the new bounds after you do the U-substitution? And for that reason, there's actually another way we can solve this problem. And it goes back to this step right here. I'm going to rewrite it down here. 1/4 times u to the 4th divided by 4 evaluated from 2 to 1. This is what we said, right, at some point in the problem. Now, if we want to, and we completely have the choice, we have two options at this stage. Number one, we can plug in for u, which we said was what again? Let me scroll up. 4x minus 6. U equals 4x minus 6. We can say that. We plug in for u. We did exactly what we did for this problem. The other thing we can do is, instead of plugging in for u, I can change my bounds, 2 up top, negative 2 on the bottom, and now I actually don't have to plug in for u. I can keep it in u. And just to prove we get the same answer, it's going to be u to the 4th over 16, because the 4 times 4 in denominator is 16, evaluated from 2 to negative 2. I plug in 2 here, 2 to the 4th over 16 minus negative 2 to the 4th over 16. You plug that in the calculator, you're going to get 16 sixteenths minus 16 sixteenths. It's 0. You get 0 both times. And the reason I compared this to the first and the second derivative test is because I think, or at least in my opinion, I don't like the change of bounds method compared to the just plugging back in for x method, because that's how we solved all our other integrals today. We actually just plug back in for x. It's easy. However, when the question asks you to change the bounds, that's when you have to do it this way. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.